In this video, we will discuss about some design best practices. Now, these design best practices that we will discuss about, these things can change. They all depend on network to network, but in general, these are some best practices that we can keep in mind before we do a deployment or a design of a network. The first and the foremost is that we need to keep in mind is deploy the AP where users actually sit. I've seen deployments where the users are sitting in the area and the APIs are deployed in the corridors. So that's not how it's going to be. Deploy the APIs where the users are actually sitting and working. If there's a bunch of users sitting in the office space, deploy the APIs right on top of them instead of deploying the APIs 7-8 meters away where the corridor is. You don't want to do that because it's not a design for location. A design of location, keeping in mind location, you deploy APIs in the corridor. That's understandable because if you're doing indoor wayfinding, then yes, people will navigate in the corridors through the corridors and try to find different locations to go to. That is where it makes sense to deploy APIs in the corridor. But in a work environment where you design on based on capacity, you have to and Wi-Fi, you have to do it where the people are actually sitting and working. So don't make this mistake. Second is design the network for 5 gigahertz. 2.4 gigahertz will follow on its own. So nowadays, in current deployments, I would say in the enterprise deployment, most of the devices which are used are capable of 5 gigahertz. So always design the network of 5 gigahertz and make sure you ask this you ask from the client first if their devices are capable of 5 or not. Usually, they have a standard model or a vendor whose laptops they distribute to the users. So that model can tell you if it supports 5 gigahertz or not. So make sure you do that research before you make a change. When you do a design, so when you choose the radio, that is if you're doing a design on 5 gigahertz, design on the power level of design on the power of approximately 30 milliwatts, which is equivalent to around 14 to 15 dB. You don't want to make sure the AP is broadcasting or blasting the traffic at the maximum power when you do a design. You don't want to do that. You want to keep some buffer if there is a need for extra coverage that AP should be able to accommodate. So design the network on the AP power which is optimal, that is 30 milliwatts. And if you design it at a high power, then there will be a chance that the client is not able to reach back to the AP. So if the RF coverage cell is created, which is very huge, the AP might still be able to send traffic to the client, but the client at sending traffic at 30 milliwatt may not be able to reach back to the AP, which will result in retransmissions and a lot of issues on the Wi-Fi. So design the network on optimal power of the radio band. The fourth is when you design a network, design with a 3 to 6 dB of delta between 2.5 gigahertz and 5 gigahertz. We have to make sure that 5 gigahertz is more attractive. So we are trying to make sure that when a client comes in the vicinity of an access point or comes in the RF coverage zone, it is attracted to 5 gigahertz more, because we want more and more clients to be pushed onto the 5 gigahertz network and not on 2.4. So if the signal strength which is received by the client is more on 5 gigahertz, they will try to connect on 5 first. So make sure you have this kind of a setup in your network where you have a 3 to 6 dB of delta between the 5 gigahertz power and the 2.4 gigahertz power when you design a network. Design for the worst case scenario. So if it's it is, there's a conference room and you expect 6 to 7 people to come and sit, but the customer says, every now and then, we do have 20 people in the conference room. Some of them are standing and still attending a conference. So you have to design the network based on that. You cannot design a network based on 7 people in a room. Or let's say, the customer says we usually use the very less data intensive application, but every now and then we do use video calls and voice calls and voice conferences. So you have to design the network on that, not on the data transfer. You have to design the conference on voice and video, or design the network on voice and video. Because if I would say 90% of the times the people use data, but the 10% of the times when they use voice and video, their experience will be really bad. So they'll raise questions on the Wi-Fi design. So you have to design the network based on the worst possible scenario, keeping this in mind always. Right? That is a smart move actually. So treat every network as high density, but do verify this from the customer. Do talk to him and check with him if this is going to be a high density network. More often than not, he'll say yes. So we have to treat it like a high density environment and then design accordingly, right? If I mean, usually what I do is I place an access point every 2000 to 2500 square feet. That's the rule that I follow. So follow that for a data design, not, I mean, voice and video, not for location. This is for Wi-Fi design. Follow this particular rule, and more often than not, you should be golden. Design for minus 65 dBm RSSI value or cell edge. So at the cell edge, the client should be able to receive at least minus 65 dBm network in the current network scenarios, right? Where the clients which are used are MacBooks or Apple devices, high-end Android devices, iPads, iPhones. So make sure, to optimize the roaming properly and the clients are able to roam at the good amount of signal. Make sure the cell edge is at least minus 65 dBm, or in some scenarios minus 66, 67 also will fly. But since we are assuming every network to be a high density network, we want to make sure it is set to minus 65 or minus 66 at the most. These are the rules that I use in my designing. So use as less number of SSIDs as possible. This is to reduce contention. This is to reduce the overhead, the RF overhead. We all understand that RF is a half duplex medium, and more SSIDs mean more and more beacons being sent out at 102.4 milliseconds. Now that can, to send out a beacon, the radio of the AP also has to contend and win the contention, and then only it will be able to send a beacon in the beacon transfer time. So we need to make sure we have as less number of SSIDs as possible. Sometimes customers are excited that their access points can support 16 SSIDs. Yes, the radio can support it, but you have to make sure you tell the adverse effect of that on the network to the customer. Train them, let them know. And I've seen customers just use different SSIDs even on the same VLAN. That is literally, that is something which should never be done. If you're using the same broadcast domain, might as well use the same SSID. So ideally, use one for the employees, which is a corporate SSID, use one for the guest, and probably use one for testing. But make sure you turn the testing SSID off whenever the testing is not going on. So 2 or 3 SSIDs should be more than enough to run a good network. Anything more than that, you have to probably relook at the design and then understand the use case of that SSID first. Design for capacity and not coverage. If I'm asked to cover an office floor just for coverage, I can cover the entire office floor with a couple of APs, but we don't want to do that. We want to make sure we design for capacity, that is the number of users, the applications they use, and the use cases on the ground, rather than just giving them Wi-Fi signal. We don't want to do that. So always design for capacity and never for coverage, right? The next thing that I want to discuss with you in the best practices is, let's say you are migrating the network, the Wi-Fi, uh, let's say from 802.11n or 802.11ac to 802.11ax now, right? So when you're doing a migration, this is the best time to reevaluate your Wi-Fi design. Absolutely the best time, because it's not easy for every now and then for clients to go and reevaluate their Wi-Fi, and there's any change, then they need to pull the cables out and do 100 things, take 100 permissions, and then it's not easy to do. So when you're doing a migration from .11n to .11ac, this is the best time to do a reevaluation of the Wi-Fi network. So check, just make sure you check if the network is coverage based, which when it was designed, or it is capacity based, right? If it is coverage based, you have to go for a redesign all the time. Redesign for capacity, right? If it's capacity based, then just check if the users are complaining or the users are not complaining. No user complaints, right? If the users are complaining, by all means redesign for capacity. Redesign for capacity needs. If the users are not complaining, right, then two scenarios come up. One is, do you expect the network usage to increase or not? Do we expect network usage to increase in the future, or we do not expect the network usage to increase, right? If we expect the network coverage to, or the network usage to increase, then we have to redesign for capacity needs. If we do not expect the network coverage or network usage to increase, then go ahead and do a one-to-one swap. Take out the .11n AP or AC AP and put a .11 AX AP. You're good. But in most of the scenarios, you have to go for a redesign for capacity. In this scenario, you do it in this scenario, right? You do it in this scenario. So in just one scenario where you do not expect the network usage to increase in the future, you do a one-to-one swap. In every other scenario, you have to redesign for capacity. So these are the few guidelines that you can keep in mind when you do a design of a network or do you perform a site survey. Keep these things in mind, and I think your network designing skill set will really increase, and I think you should do really good in this field once you follow these best practices. Thank you.